Hello everyone and welcome to Sally in Bytes. Today, I am here to teach Chapter 4, Python Programming Fundamentals, for the Class 11 students of Computer Science. In this video, we are going to discuss about Python syntax and character set, tokens, concept of an object, variables and data types, identity of the variable or object, type of the variable or object, values of the variable or object and practical implementation. So, let's dive in and get started. Now, let's learn about the Python syntax. What is a Python syntax? Python syntax refers to a set of rules that defines how users and the system should write and interpret a Python program. So, before that you should understand about the variables and data types. In Python programming language, data types are inbuilt. Whatever values we assign to the variables, the data types of the variable will be the same as the data type of the value. Hence, it is said that Python supports dynamic typing. Now, let's discuss about the basic elements of Python. Python character set. Character set is a set of valid characters recognized by Python. A character represents any letter, digit, or any other symbol. The Python language uses the ASCII character set, which is a subset of the Unicode character set. Letters. Uppercase A to Z, lowercase a to Z, digits, 0 to 9. Special symbols. Addition, subtraction, division, multiplication, backslash, exponentiation, parentheses, integer division, and so on. White spaces include blank space, tabs, carriage return, new line, form feed. Other characters, all other 256 ASCII and Unicode characters. The next basic element of Python is tokens. A token is the smallest individual unit of a program that has meaning. Python programs are made up of various types of tokens, which includes identifiers, keywords, literals, operators and delimiters. Let's learn one by one. Let's learn about the first token, identifier. Identifiers are the names given to any variables, constant, functions or modules, classes in a program. Some of the rules for defining identifiers are given here. First character of an identifier should start with a character or an underscore but not with a digit. No special characters are allowed except underscore. Reserved words, keywords, cannot be used as an identifier name, for example, reserved words like print function. Space is not allowed. Upper and lower case are treated differently. Examples of valid identifiers are ABC, X24Y, California _123, swap, name, etc. Examples of invalid identifiers are 12-digit. Here, first character of an identifier should start with a character, but it starts with 1, it's a digit. So, it is invalid identifier. Roll number, here space should not be allowed, so, it is invalid identifier. Name $, no special characters are allowed. It's invalid. Pin code, here no space allowed. So it's invalid. The next token in Python is the keyword. Keyword is the reserved words of Python that have a special fixed meaning for the interpreter. No keyword can be used as an identifier, as keywords have specific meaning for the interpreter. For example, if, else, while, for, def and class. The next token in Python is the literals. A fixed numeric or non-numeric values that are directly used in a program is called a literal. Such as numbers, strings, Boolean values, or other data that represents values to be stored in variables. They are also known as constants. Here is the list of types of literals and examples. String literals, A equals XYZ, B equals Mississippi, etc. Numeric literals, A equals 5, P equals 2,500, etc. Floating literals, salary equals 30,000.00, area equals 2.5, etc. Boolean literals, value equals true, value 2 equals false, etc. Collection literals, list 1 equals 1, 2, 3, 4, 5, tuple 1 equals 10, 20, 30, 40, 50, etc. The next token in Python is the operators. A symbol or a word used to perform operations on data and returns the result. Example, arithmetic operators, addition, subtraction, multiplication, division, comparison operators, equal to, not equal to, less than, greater than, and logical operators, and, or, not. The next token in Python is the delimiters. The symbols used as separators of values or to enclose some values. For example, parentheses, braces, lists, commas, semicolon, and colon. Python uses whitespace to separate tokens, which means that spaces, tabs, and line breaks are all used to delimit tokens in a program. This makes Python code easy to read and write, and also helps to ensure that the code is structured correctly. Here you can see an example for identifying the tokens in Python script. Observe the following script and enlist all the tokens used in it. For each token, write its category to x equals 68, y equals 12, z equals x/y, print x, y, z r, x, y, z. Here, x, y and z are identifier or variable. Print is a keyword. Equal to and slash are delimiters or operators. 68, 12, x, y, z are our literals. Python treats every value or data item, numeric, string or other type, as an object, which means it can be assigned to some variable or can be passed to a function as an argument. In Python, every object has a unique identity, ID, which remains the same for the lifetime of that object. ID is related to the memory address of the object. The function ID returns the identity of an object. For example, x equals 40. ID of x is 1637301104, which is the memory address. Now, y equals 60 minus 20. ID of y is 1637301104, which is the memory address. The memory address of identity of y is same as that of x since both hold the same value, 40. Sometimes we need computers to remember the information we give it and that it calculates during programs. A variable can be thought of as a box that the computer can use to store a value. The value held in that box can change or vary. In Python, variables are used to store values, such as numbers, strings, or other data types. Through a variable we store the value in the memory of a computer. Variable is a named unit of storage. A program manipulates its value. Every variable has a type, and this type defines the format and behavior of the variable. Let's see about variables, working with numbers. A variable is a name that refers to a value. You can assign a value to a variable using the equal sign operator. Here's an example: x equals 5. In this example, x is the variable name, and 5 is the value that is being assigned to it. Whenever a variable name occurs in an expression, the interpreter replaces it with the value of that particular variable. A variable is an identifier or placeholder that holds a value. In other words, a variable is a reference to a computer memory location where the value is stored. In Python, every element is termed as an object. Hence, a variable is also an object in Python. Some more examples of variables using numbers in Python. Look at example 1. In interactive mode, here, variable x holds the value 3, variable y holds the value 4, variable z holds the value x plus y, so z equals 7. Now z equals z plus 1. So z equals 8. Now variable x hold the value of y, that is 4. So x equals 4 and y equals 5. Hence, the output will be displayed as x equals 4, y equals 5 and z equals 8 in the same window immediately. But look at example 2. In script mode, here, variable x holds the value 3, variable y holds the value 4, variable z holds the value x plus y, so z equals 7. Now z equals z plus 1. So z equals 8. Now variable x hold the value of y, that is 4. So x equals 4 and y equals 5. Here print function is used to print the values of variables in x, y, and z. Then, for the output to get displayed, we have to save the code with a suitable file name with the extension .py and then run it, run module or press F5. Already, we have learned about how to use interactive mode and script mode in the previous video, Getting Started with Python. You can check it for reference. A Python program can use as many variables as it needs it to. All variables or objects are made up of three main components: identity of the variable or object, type of the variable or object, and value of the variable or object. The first main component of a variable is the identity. Identity of a variable refers to the variable's address in the memory, which does not change once it has been created. The address of an object can be checked using the method id of variable or object, which is the syntax or rule. For example, variable x holds the value 10. When we print the identity, that is id of x, the output displays 140652663 for 145296, which is the address of memory location storing value 10. The second main component of a variable is the type, that is data type. In Python, data type refers to the type of value that a variable or an expression represents. A data type in Python can be categorized as numbers, sequences, mappings, and none. Numbers are categorized as integer, Boolean, floating point, and complex numbers. Sequences are categorized as strings, lists, and tuple. Mappings are categorized as dictionary. Let's see the data types in a detailed manner. Number data type stores numerical values. Types of built-in numeric data types are integer, Boolean, floating point, and complex. Now let's see about integer. Integer is termed as int. Integer represents whole numbers without any fractional part. They can be positive or negative and have unlimited size in Python. An integer in Python can be of any length. Let's look at the examples. In example 1, a variable named x is created and assigned the value 6. This means that the value 6 is stored in the variable x. The print function is used to display the value of the variable x on the console. In this case, it will print the value 6 as output. In example 2, a variable named x is created and assigned the value -8. This means that the negative integer -8 is stored in the variable x. The print function is used to display the value of the variable x on the console. In this case, it will print the value -8 as output. In example 3, a variable named z is created and assigned the value 0. This means that the integer 0 is stored in the variable z. The print function is used to display the value of the variable z on the console. In this case, it will print the value 0 as output. In example 4, a variable named b is created and assigned the value 788899096. This means that the integer 788899096 is stored in the variable b. The print function is used to display the value of the variable b on the console. In this case, it will print the value 788899096 as output. In example 5, a variable named y is created and assigned the value -345678890. This means that the negative integer -345678890 is stored in the variable y. The print function is used to display the value of the variable y on the console. In this case, it will print the value -345678890 as output. Here, you have to note that while writing a large integer value, do not use commas to separate digits. Also, integers should not have leading zeros. Range of an integer in Python can be from -214,748,3648 to 214,748,3647, and long integer has unlimited range, subject to available memory. Next number data type includes Boolean data type. Boolean data type is a subtype of integer. It represents one of the two possible values, true or false. Any expression which can be true or false has the data type bool. A Boolean true value is non-zero, non-null, and non-empty. Let's look at the examples. In example 1, a variable named bool_1 is created and assigned the result of the Boolean expression, 62 greater than 100. The expression compares the values 62 and 100, checking if 62 is greater than 100. Since this is not true, the expression evaluates to false, and that value is assigned to the variable bool_1. The print function is used to display the value of the variable bool_1 on the console. In this case, it will print the value false as output. In example 2, a variable named bool_2 is created and assigned the result of the Boolean expression, 124 less than or equal to 224. The expression compares the values 124 and 224, checking if 124 is less than or equal to 224. Since this is true, the expression evaluates to true, and that value is assigned to the variable bool_2. The print function is used to display the value of the variable bool_2 on the console. In this case, it will print the value true as output. Next number data type includes floating point. Floating point numbers denote real numbers or floating point values, that is, numbers with fractional part. Floating point numbers are written in decimal point that separates the integer from the fractional numbers. The fractional part of a floating point number can also be 0. Let's look at the examples. In example 1, a variable named x is created and assigned the value 3.14. This means that the floating point number 3.14 is stored in the variable x. The print function is used to display the value of the variable x on the console. In this case, it will print the value 3.14 as output. In example 2, a variable named a is created and assigned the value 7268.4. This means that the floating point number 7268.4 is stored in the variable a. The print function is used to display the value of the variable a on the console. In this case, it will print the value 7268.4 as output. In example 3, a variable named y is created and assigned the value 0.0. This means that the floating point number 0.0 is stored in the variable y. The print function is used to display the value of the variable y on the console. In this case, it will print the value 0.0 as output. Next number data type includes complex numbers. Complex numbers in Python are made up of pairs of real and imaginary numbers. They take the form x plus y uppercase j or x plus y lowercase j, where x is a float and the real part of the complex number. On the other side is yj, where y is a float and j, or its lowercase indicates the square root of an imaginary number -1. This makes y the imaginary part of the complex number. Let's look at the examples. In example 1, a variable named x is created and assigned the complex number 2 plus 5j. The syntax a plus bj represents a complex number, where a is the real part and b is the imaginary part. The print function is used to display the real and imaginary parts of the complex number x on the console. X.real returns the real part of x, and x.imag returns the imaginary part of x. The output of the code will be the real part of is 2.0 and the imaginary part is 5.0. In example 2, a variable named y is created and assigned the complex number for -2j. The syntax a plus bj represents a complex number, whereas the real part in b is the imaginary part. The print function is used to display the real and imaginary parts of the complex number y on the console. y.real returns the real part of y, and y.imag returns the imaginary part of y. The output of the code will be the real part is 4.0 and the imaginary part is -2.0. In example 3, a variable named z is created and assigned the result of adding the complex numbers x and y. Both x and y are complex numbers defined earlier in example 1 and example 2. The print function is used to display the value of the variable z on the console. In this case, it will print the result of the addition of complex numbers x and y, which is 6 plus 3j, as output. Complex numbers are not extensively used in Python programming. Next data type is sequences. A sequence is a group of items with a well-defined ordering where each item is indexed by an integer. String is categorized under sequence data type. A string is a sequence of characters that can be a combination of letters, numbers and special symbols enclosed within quotation marks, single or double or triple. These quotes are not part of the string. They only define the starting and ending of the string. A string may have any character, sign, or even space in between them. Now look at the examples. In the first example, a variable named str1 is created and assigned the value hello world. The value is enclosed in double quotation marks, indicating that it is a string literal. The print function is used to display the value of the variable str1 on the console. In this case, it will print the string hello world as output. In the second example, a variable named str2 is created and assigned the value 12,345. The value is enclosed in double quotation marks, indicating that it is a string literal. The print function is used to display the value of the variable str2 on the console. In this case, it will print the string 12345 as output. It's important to note that the value of str2 is a string, even though it consists entirely of numeric characters. In Python, strings are a sequence of characters and can contain alphanumeric and special characters. In the third example, a variable named str3 is created and assigned the value Python 3.9.2. The value is enclosed in single quotation marks, indicating that it is a string literal. The print function is used to display the value of the variable str3 on the console. In this case, it will print the string Python 3.9.2 as output. Here, we can learn about the escape sequence. Python allows us to represent a string containing non-graphic characters as well. Non-graphic characters are those characters which cannot be directly typed from the keyboard, such as backspace, tab spaces, carriage return, etc. These non-graphic sequence is represented by a backslash followed by one or more characters. An escape sequence character is represented as a string with 1 byte of memory and backslash is ignored by the interpreter. Now you can pause the video and read the contents in the tabular form. Next sequence data type is lists. List is a sequence of items separated by commas and the items are enclosed in square brackets. Let's look at the example. The provided Python code demonstrates the creation and printing of a list. Let's analyze each line. In this example, a variable named list1 is created and assigned a list containing multiple values. The list consists of integers, 20, 33, a floating point number, 6.5, and strings, New York, D34. The print function is used to display the value of the variable list1 on the console. In this case, it will print the entire list, 20, 6.5, New York, D34, 33 as output. Next sequence data type is tuple. Tuple is a sequence of items separated by commas and items are enclosed in parentheses. Note that once created, we cannot change the tuple. Let's look at the example. The provided Python code demonstrates the creation and printing of a tuple. In this example, a variable named tup1 is created and assigned a tuple containing multiple values. The tuple consists of integers, 180, strings, sam, p, and a floating point number, 4.5. The print function is used to display the value of the variable tup1 on the console. In this case, it will print the entire tuple, 180, sam, 4.5, p, as output. Next data type is mapping. A mapping object maps immutable values to arbitrary objects. This data type is ordered and mutable. There is currently only one standard mapping type, the dictionary. A dictionary holds data items in key-value pairs and is accessed using keys, which are immutable data type and their values of any data type. Items in a dictionary is enclosed in curly brackets. Dictionaries permit faster access to data. Every key is separated from its value using a colon sign. In order to access any value in the dictionary, we have to specify its key in square brackets. Now look at the example. The provided Python code demonstrates the creation and printing of a dictionary. In this example, a variable named dict is created and assigned a dictionary containing key-value pairs. The keys are strings, name, age, class, and the corresponding values are nishant, 16, and 11. The print function is used to display the value of the variable dict on the console. In this case, it will print the entire dictionary, name, nishant, age, 16, class, 11, as output. Next data type is none data type. None is a built-in constant in Python that represents the absence of a value or the null value. This is a special data type with a single value. It is used to signify the absence of value or condition evaluating to false in a situation. It is represented by none. Python doesn't display anything when we give a command to display the value of a variable containing value as none. None will be displayed by printing the value of the variable containing none using print statement. Now, look at this example. A variable named value1 is created and assigned the value 30. This means that the integer 30 is stored in the variable value1. Next, a variable named value2 is created and assigned the special value none. None is a built-in constant in Python that represents the absence of a value or the null value. The print function is used to display the values of the variables value1 and value2 on the console. The output of the code will be 30 and none. This means that the value 30 will be displayed on the first line of the console when the code is executed, and none will be displayed on the second line. Until now, we have completed the identity of a variable and data types of a variable. Next, we will learn about the values of a variable or object. In Python, you can create variables and assign values to them using the assignment operator =. Look at the example 1. In this example, a variable named mathematics and assigns it the value 98. Print function outputs the value of the variable mathematics as 98. Here you have to note that in an assignment statement, the variable must be on the left side of the assignment =sign operator, otherwise it will generate error. Look at the example 2, 98 equals mathematics. We have reversed the order and attempted to assign a value to the literal 98, which is not permissible. The error message we encountered is, syntax error, cannot assign to literal, occurs because we are trying to assign a value to a literal, which is not allowed in Python. Let's learn about the concept of the L value and R value. The L value represents an object that occupies some identifiable address in memory. The variable which is at the left-hand side of an assignment operator is called the left value or the L value. The variable which is at the right-hand side of an assignment operator is called the right value or the R value. The statement, L value equals R value, is called the assignment statement. When the interpreter encounters an assignment statement, it evaluates the right-hand side expression, R value, and assigns to the left-hand side variable, L value. In example 1, according to the operator precedence, the multiplication, asterisk, is performed before the addition, plus. So, the expression 2 times 2 is evaluated first, resulting in 4. Then, the addition is performed, 8 plus 4, which gives the final result of 12. And assign this value 12 to the variable value 1. Its value will be 12 until it is changed by another assignment statement. In example 2, with two variables x and y, and we type the following assignment statements. X equals 3. Here, variable x is assigned 3 as a value. Next is, y equals 3. Here, variable y is also assigned value 3, so now y shall be pointing to x only. Next, y equals 2. Here, variable y is assigned another value 2. Now the final value of y becomes 2 and that of x remains 3 as assignment operator erases the previous value and assigns new value to the variable y. Thus, it becomes evident that we can use assignment operator for assigning values to a variable along with their reassignment. In Python, we can declare multiple variables in a single statement. It is used to enhance the readability of the program. It can be done in two ways. Assigning multiple values to multiple variables and assigning same value to multiple variables. First, we will discuss about the assigning multiple values to multiple variables. var1, var2, var3, varn equals value 1, value 2, value 3, value n. This statement will declare variables var1, var2, varn with values as value 1, value 2, value n respectively. Let's look at the example 1. The variable message is assigned the value meeting, the variable day is assigned the value mon, and the variable time is assigned the value 9. After executing this code, message holds the value meeting, day holds the value mon, time holds the value 9. Please note that the value assigned to time is a string 9, not the numerical value 9. In example 2, the variable x is assigned the value 2, and the variable y is assigned the value 3. After executing this code, x holds the value 2 and y holds the value 3. Second way is to assign same value to multiple variables. var1 equals var2 equals var3 equals varn equals value 1. This statement will declare variables var1, var2 up to varn, all with value as value 1. In example 1, the code total marks equals count equals 0 assigns the value 0 to both the variables total marks and count simultaneously. In example 2, the variable x is assigned the value 3, y is assigned the value 60, z is assigned the value 54.5, and p is assigned the string value %. After executing this code, x holds the value 3, y holds the value 60, z holds the value 54.5, p holds the string value %. In example 3, the code a equals b equals c equals -5 assigns the value -5 to all three variables a, b, and c in a single line. After executing this code, the variables a, b, and c will have the value -5. In example 4, since a, b, and c have all been assigned the value -5, the expression a plus b plus c will yield -5 plus, -5, plus, -5, which simplifies to -15. Next, we can learn about variable name. Rules are as follows. A variable name must start with an alphabet, capital or small, or an underscore character. A variable name cannot contain spaces. A variable name can contain any number of letters, digits, and underscore. No other characters apart from these are allowed. A Python keyword cannot be used as a variable name. Variable names are case-sensitive, that is, lowercase name and uppercase name are two different variables. You should always choose names for your variables that give an indication of what they are used for. In other words, the name should reflect its functionality. Valid variable names: unit underscore per underscore day, day of week, stud underscore name, father underscore name, total marks, age, amount, A24, invoice underscore now. Invalid variable names. 3D graph, name cannot start with a digit. Role hashtag no. Special symbol, hashtag, is not allowed. First name. Spaces are not allowed in between. D.O.B, dots are not allowed. While. Keyword not allowed. Example 1. Write a Python script to input two numbers and find their sum and product. Now, look at the code for line-by-line explanation. The code starts by prompting the user to enter the first number using the input function and displaying the message, enter first number. The user's input is stored in the variable n1. The eval function is then used to evaluate the value of n1. This eval function takes a string as input and interprets it as a Python expression, returning the result. In this case, it converts the user's input, which is initially a string, into a numerical value and assigns it back to the n1 variable. This step ensures that the input is treated as a number rather than a string. Next, the code prompts the user to enter the second number using the input function and displays the message, enter second number. The user's input is stored in the variable n2. Similarly to the previous step, the eval function is used to evaluate the value of n2, converting it from a string to a numerical value and assigning it back to the n2 variable. The code then calculates the sum of n1 and n2 by adding them together and assigns the result to the variable sum. It uses the print function to display the calculated sum to the user, along with the message, sum of the numbers equals. Similarly, the code calculates the product of n1 and n2 by multiplying them together and assigns the result to the variable prod. It uses the print function again to display the calculated product to the user, along with the message, product of the numbers equals. So now look at the output below, enter the first number 50, enter the second number 60. Sum of the numbers 110. Product of the numbers 3000. Example 2. A student has to travel a distance of 450 kilometers by car at a certain average speed. Write a Python script to find the total time taken to cover the distance. Now, look at the code. The code sets the value of the variable distance to 450, representing a distance in some unit kilometers. The code prompts the user to enter the average speed using the input function and displays the message enter average speed. The user's input is converted to a numerical value using the eval function and stored in the variable speed. The code calculates the time taken to travel the given distance by dividing the distance by the speed and assigns the result to the variable time. The code uses the print function to display the value of distance along with the message, distance is. Similarly, it uses the print function to display the calculated value of time along with the message, time taken, and adds the string, HR, to indicate that the unit of time is hours. So now look at the output below. Enter average speed 60. Distance is 450. Time taken 7.5 hours. Example 3. Write a Python code to calculate simple interest by inputting the value of principal amount and rate from the user for a time period of 5 years. Now look at the code. The code prompts the user to enter the value of the principal using the input function and displays the message, enter the value of principal. The user's input is converted to a numerical value using the eval function and stored in the variable principal. Similarly, the code prompts the user to enter the annual rate of interest and stores the input in the variable rate after converting it to a numerical value. The variable time is set to a value of 5, representing the time period in years. The code calculates the simple interest by multiplying the principal, rate, and time, and then dividing the result by 100. The calculated simple interest is assigned to the variable simple_int. The code calculates the total amount payable by adding the principal and the simple_int together. The calculated amount payable is assigned to the variable amount. The code uses the print function to display the calculated simple interest along with the message, simple interest equals Rs. Similarly, it uses the print function to display the calculated amount payable along with the message, amount payable equals Rs. Now look at the output. Enter the value of the principal 25,000, enter the annual rate of interest 6.5, simple interest equals 8,125 rupees, amount payable equals 33,125 rupees. Example 4. Write a Python code to convert the time inputted in minutes into hours and remaining minutes. The code prompts the user to enter the time in minutes using the input function and displays the message enter the time in minutes. The user's input is converted to an integer using the int function and stored in the variable time. The code calculates the number of hours by performing integer division on time by 60. This operation discards the remainder and gives the whole number of hours. The calculated number of hours is assigned to the variable hours. The code calculates the remaining minutes by using the modulo operator on time with 60. This operation gives the remainder after dividing time by 60. The calculated remaining minutes are assigned to the variable mints. The code uses the print function to display the calculated number of hours along with the message, hours are. Similarly, it uses the print function to display the calculated remaining minutes along with the message, minutes are. Now look at the output. Enter the time taken in minutes 16:30. Hours are 27 and minutes are 10. Thanks for watching. Watch the upcoming videos. Chapter 4, Python Programming Fundamentals, Part 2, which includes usage of Python data types, mutable and immutable data type, keywords, expressions, and operators. You can check the link in the description box below.